So, okay, so continuing on the review. So for finding the equation of the line, you need to identify the slope and the y-intercept. And usually you can solve for the y-intercept by either looking at the graph or plugging in some random x and y value that is on the line. And then you can solve for the slope by rise over run. And you plug in the slope and the y-intercept, and then you get y equals mx plus b. And you can use any equation in that form to graph a line. Okay.
So the first example, find the equation of the line if the line passes through the points 6, 8 and 9, 14. So remember how we would do this again? We just do like, we'd find the slope and then the y-intercept, and then we just find the equation of the line from those two things, right? I'll wait like a minute for responses, people to find the equation.
So a hint is like, we would have a point like 6.
Okay, so we have three correct answers. Oh, 4 now. Okay, let's go. This is great. So we just remember we find the slope of the line. We're going to write the equation in slope-intercept form, which is just y equals mx plus b. And so we find the slope of the line, which is y2 minus y1 over x2 minus x1. And in this case, y2 is going to be 14, and y2 is going to be 14, y1 is going to be 8. So it's going to be 14 minus 8 divided by, and then x2 is going to be 9, and x1 is going to be 6. So it's going to be 14 minus 8 over 9 minus 6 to find the slope. And then 14 minus 8 is 6, and then 9 minus 6 is 3. So 6 divided by 3 gives our slope of 2. So right now our equation is y is equal to 2x plus b. So, and then we can substitute one of the 2 points that they give us here to find b in this, and it'll give us y8 is equal. So say we substitute 6, 8. We get 8 is equal to 2 times 6 plus b. So 8 is equal to 12 plus b, and b is going to be equal to -4. So that's true. So our equation is going to be y is equal to 2x minus 4.
Okay, so find the equation of a line that passes through the point 0, 7 and 9, 4. So this is very similar to what we just did in the first example. So hopefully you guys can try this one. Okay, so once we have like 2 more answers, I'll reveal the answer. Okay, just 1 more answer now. Yeah, so out of like the 4 people that answered, if you want, one of you can like volunteer and I can give you, yeah. So if you want to explain how you got it, okay. So
So what I did first, so to find the slope, I first did 4 minus 7 over 9 minus 0. So I got minus 3 over 9. So that becomes minus 1/3. So then right now I have y equals minus 1/3 x plus b. So first I did y. So I used the coordinate points 9, 4. So I did y equals minus, or 4 equals minus 1/3 times 9, or minus 3 plus b. Then I just added 3 in both sides, which give me 7 equals b. Or if I want to try it another way, I could also do, since we already know y equals 1/2 x, 1 minus 1/3 x plus 7, I could test it out by using the coordinate 0, 7 also, which gives us, which proves that it's correct.
Yeah, that's correct. That's right.
yeah, good job. Also, I tried to give you like remote control, but for some reason, your name isn't popping up. So anyways,
All right. So as we said earlier, slope intercept is y equals mx plus b. M is the slope and b is the y-intercept. So this is usually going to be the most convenient way to do anything involving involving a line, whether it's graphing, finding the slope, finding the intercept. This is usually what you want to do.
Point slope form is another one of the common forms that you're going to see linear equations in, and it's going to be y minus y1 is equal to m times x minus x1, and just like point slope, or just like slope intercept form, m is going to be the slope here, and then x1 comma y1 is going to just be any like random point along the line. And it's good to find a point on the line. Using this form, it's good to find a point on the line for which you know the slope and another point on the line. So like you can easily write the equation. You can easily write the equation of a line if you know the point and the slope.
okay, so now we're gonna go to solving systems of equations. So
Okay, so there's 2 methods when it comes to solving systems of equations. One is substitution and the other is elimination. So first we're going to go over substitution. So to do substitution, you solve for one of the variables in terms of the rest of the variables, and then you substitute it into the original equation and solve for that variable. So I know this sounds a little bit confusing, so we're gonna go over an example on the next slide. So solving for the systems of equation using substitution for x plus y equals 3 and 3y plus x equals 5. So as we said in the previous slide, we should try to isolate one of the variables. So when we have x plus y equals 3, we have x equals y plus 3. So now we've solved for one of the variables, and that would be x. We've expressed it in terms of y. So Now what we're going to do here is we're going to plug in our value of x into the second equation. So now we have 3y plus y plus 3 equals 5. And so now we just solve for y, which equals 1/2. And then we substitute 1/2 into our original equation. We get x equals 2.5. So the solution is 2.5 comma 1/2. Wouldn't it be 3?
Are we talking about like right here? Yeah, it should be x equals 3 minus. So like this. Okay, well, if we plug this in instead, so instead of this a minus, and then yeah, so then it'd be 2y plus 3 equals 5. So that means 2y is equal to 2. So y would be 1. So sorry about this, guys. And then we plug in y into one of our equations. So we put in 1 here. So then x is 2. So our solution is actually 2 comma 1. So thank you for catching that. The people who said that. So yeah, hopefully that wasn't confusing. Oh, and also you can't plug this part in like x equals y negative y plus 3 into your first equation because that's the equation you just rearranged. So you have to instead put it into the second equation. Because if you put it into the first one, it won't work because you're putting like your equation into your equation. Okay.
So we can use elimination when we realize that a like term and two equations with the same coefficient are given. So if this wording is hard to understand, don't worry, we're going to look at an example. But basically the idea when you're doing elimination is that you want to get the coefficient or like that number right before the x, like when you're multiplying 3 by x, you want to, it's kind of like doing the least common multiple between two numbers. So like for example, right here, 2y, the two y's in both equations are like the same. And so you can end up subtracting both equations from each other. And you'll get like negative 4x is equal to negative 8. And then that'll give us x is equal to 2 because the two y's, they like cancel out, right? Because you subtracted them from each other. Yeah, so then you substitute, you get 2 for x and you substitute the x back into the first equation and then you get like 6 plus 2y is equal to 7. So then y is going to be 1/2.
So here you're just like basically trying to subtract, like do something with the two equations to get rid of one of the variables. Oh, oops. Okay. So our next one is graphing. So one method for solving systems is to just simply graph both lines and find the point at which they intersect. So if we have these two equations we see on the left, so 4x minus 2y equals 4, and then x plus y equals 4. If we would just graph these like you see on the screen, you can just find the point at which they intersect, so like this point, and that would be your answer. So if you guys want to like take a look at this graph and type in the chat what the answer would be for these two equations, their point of intersection. So all you have to do is just look at this graph and tell me what that point is. Yeah, so it's just 2 comma 2. So our answer would be 2 comma 2.
All right, so now we're gonna go over the equal value method. Wait, what's the, okay. Oh, okay, it's just when we said, okay. So usually you're gonna have two equations in like the layout of y equals some expression and then y equals some expression. So I mean, you could use something like elimination or substitution, but that'd be kind of dumb just because you have they're already, you know, equal. So you can just set the two expressions equal to each other and then solve for whatever x is. So an example of this would be so y equals 3x plus 4 and y equals negative 2x plus 9. So both halves equal to y. So if you just set them equal to each other, you can solve for x equals 1. And then you can plug x equals 1 into either of these equations. You're going to get 7 for both ones. And then you're going to get 1 comma 7. All right, so example 2. So we have y equals 4x minus 9 and y equals x minus 3. So I actually want you guys to solve this one just because we went over it in the previous question. So I think you guys should attempt to solve this. I think we're gonna wait for a couple more answers. Well, not a couple more answers. We've only gotten one. So if you feel uncomfortable typing your answer in the general chat, you can just like private message either of us. Okay, so we've gotten some more answers, so we can go over it now. So when we set the equations equal to each other, we get 4x minus 9 equals x minus 3. So when we solve for x, we get x equals 2. And then we just plug in x equals 2 into our original equations, we get 2 comma negative 1. So that's really all you need to do to solve for this system of equations. So if anybody doesn't understand that, please ask questions. These are the fundamentals. So, having any confusion would not be good. Yeah.
Okay. Determining which of like the four, like the three methods, I guess, to solve a question, it always will come with practice. Like as of now, if you ask any of us, we'll probably be able to look at an equation and almost immediately identify what to do with it. And it's like it mainly comes with practicing problems, and that's what you need to do in math all the time to
And
be able to
practicing also
drill down the
speed.
concepts. You need to always practice actual problems.
Okay, so we're gonna do a little bit of practice right now. So you guys have 10 minutes to solve these 5 systems of equations. And for the first 3, say which method out of the ones we just went over, like substitution, elimination, equal value method, like that, say which one you use to solve. And then for the last 2, just solve them. So just to let you know, you can use like any of the methods for any 2 systems of equations, but it's like sometimes a certain method will be easier than others, so it would be more efficient. But just try your best for now and just say which one you use to solve. And yeah, so we'll give you 10 minutes or until like a handful of people answer. Yeah, so you do solve all 5, and you could like say number 1 is this comma that, number 2 is this comma that, like that. So all in one message would be nice.
Okay, so once you guys are done with these questions, I actually have one question that I want to go over that is a little bit different from typical systems of equations, but it's more similar to questions that you're actually going to see. So I want you guys to attempt to solve that as well. It might be a little bit challenging, but it is going to be more important. So once you guys are done finishing these questions, I want to go over that.
Let's go over these at like 10, 15.
Yeah, that's a good
Well,
idea.
Like if you're not done by them, we can just go over like them one by one together as a group.
And also there's 18 students in this class, but only like 3 are putting their answers in the chat. So if you guys are having any trouble with these questions, you like need to ask, your question, just because you have to be able to solve these. Like at some point in time, you're gonna have to know this stuff really well. So if you want to do good on the AMC. So yeah.
Should I post a link to the gym in the chat or?
Yeah, we can do that. Okay, it's on the homework review one. It's like slide number 7.
Wait.
Wait, what are we doing on the gym group?
I have this one question I want to go over.
Oh, okay. Should we do that after we go over these 5?
Yeah, sure. We can do.
Okay. So we're gonna go over these first 5 first. So it's okay if you didn't finish, but just pay attention to what we're doing now. So our first question, so in the chat, if you guys can, could you please just take a guess at which method would be best for this first one right here? So it's okay if it's wrong, you can just take a guess. Okay, so we have an equal operation. Yeah, so equal value method where you have like y equals in both of the equations would be very useful in this situation since we have y equals here and here. So we can just set these two parts equal to each other. So like go with 7x minus 6. And you would just solve for x here. What about the second one? What would you use? Okay, so I see an elimination. So if like 3 more people just want to like take a guess, even. Okay, so 2 eliminations. Okay, so a few of you are saying elimination, which is probably the best method because you can see that there's a 3y in both of these. So if you just subtract like this equation from this equation or the other way around, you can eliminate the y's so you can solve for x that way. And then what about this third one? Okay, so I see a substitution. So if a couple of you want to take a guess, hint, we've learned like 3 methods and we've already looked at 2 of them. So it should be the last one. Yeah, so it is substitution because if you can see here, this first equation, you can just move, like add y to both sides, which would get us x is equal to y plus 6. And then we can just substitute this into where x is in the second equation and just solve for y and then solve for x. So thank you to all of you that answered. And then, and the answers were, for the first one, like 3, 15. For the second one, -2, -3. And then the third one, our answer is in decimal form. So 4.4, -1.6. And then for these last 2, I'll just like take an answer for these and say if it's right or wrong. Okay, so number 4, I see a couple of people saying -2/3, 1. So yeah, you can answer. So I'm gonna see if your name pops up on here. No. So if you want, you can just like unmute and explain how you solve this question.
Just subtracted off both equations. So it became 3x plus 5y equals 3 minus 3x plus 7y equals 9. So that became 12y equals 12 and y equals 1. And then I substituted that into the first equation. So it became 3x plus 5 equals 3, or 3x equals minus 2. And then I divide by 3, which gives me x equals minus 2/3.
Yeah, so that was a good explanation. So the answer is this. And what about this very last one? So I feel like you guys might not have been able to get to this because we didn't have time. But basically, so you could do like a substitution here and divide both sides by 4 and solve for x, then put this into the second equation. So our answer after you do that is 6.9, 7.9. And for these problems, if you didn't completely understand all of them right now, you'll have like access to these slides, so you can look over them again on your own time.
You can also do extra practice questions at home. And if you needed help with anything, you can email any one of us.
Yeah, or ask next class if you want to like talk. So let's go to the Jamboard.
Yeah, so it's just a homework review. I think it's going to be way better if we do some like real questions, like some.
Not this one.
Oh,
Not this gym, but it's the homework review.
The homework review.
I can't exit out. How do I close this tab?
Press the X.
I know, but like
Press the X button.
No, it's like covering it, like the screen sharing part.
Okay, it's fine. I'll just send
Whatever. Can you just put the link again in the chat?
Yeah, I'll do that. Should I do editor or viewer?
I don't know. I don't care.
Okay, so everybody go to that link. Go to the 7th slide. I want to see at least like 7, 8 people on this at minimum. Go to the 7th slide. We're gonna go over 7, 8, and 9. So some real AMC questions. All right, so we have like 1, 2, 3, 4, like 4 people. There's 5. So we have some more. I want some more people to join.
Right, guys, there are like 18 people or like 15 people in this class, but like half of you guys aren't even on the Jamboard.
Loading for me.
All right.
Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10. I'm just gonna go over it. So me and Gopal and Kyung are gonna go over some of these questions. So the first one, if anybody wants to volunteer, try to solve it. Go
Yeah.
ahead, type your answer in the chat. We're probably gonna wait like 30, 40 seconds.
Yeah.
Yeah.
You
Go
can.
ahead, try to solve it.
Anyone can do these problems.
Anybody can.
Problems are
Yeah,
hard.
so we're on slide number 6 right now. So go ahead, try to solve it. That would be great. Yeah, take a look at it. Yeah. We'll wait until like 26.
If you want, you can like put a sticky note with your answer.
Yeah, if you would like. These are the types of questions you're going to be you want to familiarize yourself with, because the questions like 4x plus y equals 6 and some other equation, those will not appear as much. You're going to want to use more. You're going to want to solve more questions that require more problem solving skills. Okay, so I don't think many people solve this. I'm just going to go over the first one. So you can solve this using systems of equations. Honestly, I haven't even solved this either, so I'm going to have to solve it. But when you look at these numbers, 24, 48, 72, these are good numbers. And by good numbers, I mean they're easy to handle. They're divisible by numbers like 6, 12. So they're not like prime or anything. So it's pretty easy to just kind of plug in numbers and see what you get. So first we can start with we can do x
Vishwa
equals-
has an answer, and he said that the answer is
so
38.
Vishwa has the answer 38. Okay, good, nice. So we can start with a number. We can do 4, right? We can say x is 4. So if x is 4, that means y has to be 6. And I'm not sure this is right yet. I'm just kind of playing around with the question, see where it takes me. So we have x is 4, and then we have y is 6. So that means that z must be, that means z must be 12, right? Yeah, so z must be 12. And so I believe this is right. Yeah, so x times y is 24, y times z is 72, and then x times z is 48. Now I got this right first try, but I usually wouldn't, that usually would not be the case. You just kind of want to plug in numbers that seem like it could be right. Like I didn't plug in 2 to this because then that would make x too small and that would make y too large. And if you look at these numbers, there's not that much of a difference. Like I know 24 and 72 might seem like a big difference, but this is only 3 times this, and we don't want something like 2 versus 12. Okay. Does that make sense to everyone how I approach that? So the answer would be 22, because x plus y plus z is 22. We can do the next question now. But I want to know if everybody understood how I did that question. Vishwa's gonna get a free cookie. Yeah. So for numbers like this, for a question like this, you want to guess and check this, right? Like only questions like this. By questions like this, I mean when you have numbers like 24, 48, 72, then it's ideal to guess and check just because, I mean, it saves you time. Look at the numbers, right? They're divisible by,
They're all
I think,
divisible by
70.
24.
Yeah, they're all divisible by 24, right? They're multiples of each other. So they're good numbers. If you have a number like 39 and then 78, you know, oh wait, never mind. That's actually a good one. 39 and like 102, okay? In this situation, you would want to use some algebraic method. But yeah, all right, we're gonna move on to the next question now. Let x, y, and z be positive numbers satisfying this.
Can you
Uh,
move the slide?
next slide. Yeah, satisfying these two equations. Compute x, y, z. This question is a little bit trickier, but you should be able to try to simplify it and try to solve it. Yeah. A tip I would recommend is try to get rid of fractions. In AMC questions, fractions, decimals, radicals are never your friend. So the first thing you would want to do is try to get rid of fractions. Yeah, we can wait a couple of minutes for you to do it. I'm going to erase local pulpit just because no hints. AMC doesn't give you hints.
Oh wait, I didn't know that they were. Oh, I thought I made a copy.
Okay.
Oh, let's do this in my
We'll wait until 33. I know that might seem like a little like not much time, but you kind of have to get used
with
to
the
it.
pacing of an AMC, with the pacing of like a contest like Math Counts or AMC, like 2 minutes for a question is actually a lot of time, especially if they're like
In
questions
math
like
counts, you get
these.
like what, 45 seconds?
Yeah, in Math Counts you have 30 or you have 40 questions or 40 minutes, 30 questions. So
Yeah. So it's
can you give us 5 minutes to do it? I mean,
we'll give you 2, maybe 3.
as long as you get them, as long as you get the method to do the question, I don't really care about the calculations. As long as you find out like the method or the overall strategy when doing the question, that's what matters. Because like doing calculations is easy. Like everyone knows what 5 plus 5 is.
I want more people to be engaged. We have like 4 people that are actually listening. All right, we'll wait until 33. If you want, I can add more questions. Okay, we'll wait 1 more minute for whoever put that. Okay. All right, so we're gonna have Gopal explain it now.
Oh, okay. So for this question, basically for these kinds of questions right here, the calculations and stuff, they don't really matter. Like, what matters is like your algorithm or like your procedure and what you do. Like what clever manipulations you guys can think of when doing this problem.
Don't do guessing
that
check for
will-
this.
Yeah, what clever manipulations you guys can think of when doing these problems. And for this one, I almost immediately saw, oh yeah, I can just multiply for all four of these or all three of these equations together, and I'll be able to get something that I'll be able to like simplify. And so you said I got x times 13/25 times 38/25. Okay. Oh, so you didn't find x yet? All right. Yeah, I think that method that might be all right, but when you're doing like a time,
You don't want to use typical systems.
yeah, when you're doing a when you're in a time pressured environment like AMC 8 or like AMC 10, finding those, you want to use more like clever manipulations and not really like part bashing every single variable in the equation and writing out like 20 different equations trying to solve for x, y, and z, and then like multiplying them together. So what I did was I just multiplied x plus 1 over y times y plus 1 over z times z plus 1 over x. And if you do that, you're going to see that you're going to get a like product of x, y, z plus y plus x plus 1 over z plus z plus 1 over x plus 1 over y plus 1 over x, y, z. And that's
Yeah,
on the
so-
screen for
So
you to
this
see.
product right here, that is the product of these three expressions.
All right. And from there, you can kind of see in the question, it gives you like these, you can like start taking out variables, and it gives you the actual problem statement gives you some of the variables that are here. Like for example, I see x plus y, or x plus 1 over y. I see that is equal to 4 because that's what it says in the problem. So I can literally just get rid of these two here. And then I see z plus 1 over x. That's also in the problem. It says that that's equal to 7/3. And then y plus 1 over z. That's also in the problem, and that's equal to 1. So 1 plus 4 plus, what is it? 7/3 is x, y, z, which is what we're finding, by the way, plus 1 over x, y, z, plus this sum over here, 1 plus 4 plus 7/3, is equal to 28/3. Sorry for the bad handwriting. Using a trackpad is hard. So 5 plus 7/3, and then that's going to be 22/3. And then that's going to, so then you subtract 22/3 from both sides, right? Remember, this is where solving our linear equations comes into place. And we get this thing here, xyz plus what is it, 1 over xyz.
No, we have a question in the chat. How did you get the blue thing? So we took x plus 1 over y plus 1 over z, and x plus 1 over, z plus 1 over x. We multiplied those two expressions together, and then we multiplied their respective, the things that are equal to together. So when we multiply the three expressions together, we get x plus y plus x plus 1 over z plus 1 over x plus y over y plus 1 over x, y, z. And then the thing on the right, we got 28/3 by doing 4 times 1 times 7/3. So we just multiplied the three expressions together.
Basically, I just multiplied I just multiplied those three equations in the top, like in the question, and then I multiplied their products, like what they're equal to. So I got like an equal expression.
We have xyz plus 1 over xyz equals 6/3, I think.
And then this here, okay, yeah, I'm just gonna finish up the question now. Like right now, it's just like tedious work. So yz plus 1 over xyz is going to be equal to 2. And then so then we can like just use a different I don't see how you got a lot of these numbers, but I guess I'll understand as
But what do you understand how we got some of these numbers?
Oh, I think all right.
Like maybe the substituting part. Are you talking about like how we put in?
I think she's talking about the factoring, like the actual factoring, or like the distribution.
Oh,
like the distribution of like the binomials.
Okay, should we explain that? It's gonna be a little tedious, but I guess it's kind of necessary.
Yeah, I guess.
I mean, like from what you've learned in.
It's not really relevant to this
kind of
class, but like it's
beyond the scope of this class. But
I think we will. Okay, keep that in mind. We'll go over that next class because we're gonna cover more stuff like that next class, more stuff like factoring. So remind us next class on Thursday. Take note, and then we'll go over this exact example because I think then would be a better time to go over this. Okay.
Yeah.
Yeah. Okay. Sounds good. I think we're gonna go over the third one now.
Yeah. All right.
Yeah. So now we're just solving for this xyz plus 1 over xyz.
I'm just doing this for fun.
Oh, okay. All right.
You guys can move on.
Okay. So the next question. I haven't solved this one either. So we have x plus y plus square root x plus y equals 30, and then x minus y plus square root x minus y equals 12. So, okay. So as I said earlier, we want to eliminate variables. We always want to eliminate, not variables, we want to eliminate radicals. Radicals, fractions, and decimals are our enemies because they just overcomplicate everything, right? So we're gonna set a variable for this, and we're gonna set a variable for this, okay? For each of these radical expressions. So let's say that x plus y, the square root of x plus y equals, we'll call this variable, we'll say it's u, okay? U. And then we'll do the square root of x minus y. We'll say that's equal to v. Okay, I'm going to say v is black just because v and u look similar. So v, okay? I don't think I'm going to use u because u and v look so similar. I think I'm going to put like a. I'll put a. Yeah, a is a good one. A, okay? Does everybody understand what I did so far? So now what we're going to do is we're going to we're going to square A and we're going to square V. Okay. So now we're going to get X plus Y plus, oh wait, never mind. I think I know a better way to do this.
Oh no, you're doing it right.
Oh yeah,
so
okay,
far.
I know. So now we have X plus Y, so the square root of X plus Y is A. So that means that X plus Y is just A squared, right? So now we have A squared plus A equals 30. Okay. Does everybody understand what me and Gopal did here? So since we have the square root of X plus Y equals A, X plus Y plus the square root of X plus Y equals A squared plus A equals 30, right? Does everybody get that part? Yes. Okay. Also, the answer to the previous question was 1. The one that was the product of X, Y, Z. It's just 1.
The answer to that question was 1. Made me do all that just to get
You could have just guessed 1.
Exactly. That's what some people would have done. They would have just been
Some
like, this
people just
question is
guessed
too
1.
hard. The answer's 1. I'll
It's
just
a
go.
troll question.
Let's
Yeah, the
move on.
answer is just 1. It's like such a complex question, but the answer is just 1. Okay, so now we're going to solve for A and V. So in the first equation, A could equal 5, and then A could equal what, like -6, I think? Yeah, -6. In the second one, V could equal 3 and -4. Okay, so V could equal 3 and V could equal -4. Does everybody understand how this is true? Because like 3 squared plus 3 is 12. -4 squared plus -4 is 12. Let me check chat. Okay, yes. All right, good. Now, all right, let me see what to do here.
And now you guys can actually use your
now
linear
we can use
equations that you learned.
Yeah.
Elimination
It's actually very
specifically.
simple from here.
Elimination
Yeah,
specifically.
I want to see if anybody can solve it from here. I'm just gonna let somebody else try, and then I'll explain that after. Now that we've solved for the values of U and let's solve for the values of V. There's A, sorry. Yeah. Also, only use the okay, I want you guys to solve from here, but the thing is, only use this. Only use this part, A equals 5 and B equals 3, because as I said yesterday, principal square root is always positive, and this will usually be positive. So only use A equals 5 and B equals 3. I think we could disregard the negative because that's not the principal square root. So solve for the positives, and remember what A and B are equal to.
Yeah, so just use just use the equations that we wrote on the we found that A is equal to 5 and that V is equal to 3. And at the beginning of the problem, we defined A and V as x plus the square root of x plus y and the square root of x minus y respectively. So now we're just finishing up the problem and finding x plus y and x minus y.
So I'm just saying to like try to solve it from here. If you can't, that's fine. We can go for it.
So Shreyan said
X
is equal to 17 and y is equal to 8.
I think that's right. Yeah. Yeah, x equals 17 and y equals 8. Shreyan, do you want to explain how you got that? Or does anybody want to explain? It is 17, 8. So If anybody wants to explain, they can explain. Troyan gets a gold. Yeah, Advika, you can explain. Essentially what we're doing is we're just getting x plus y equals 25 and x minus y equals 9. And then we're just solving for that system of equations. Yeah, you can explain. Go ahead. You can write on the Jamboard, you can unmute, you can do whatever you like.
Now that we know that now that we're going to use a equals 5 and b equals 3, x plus y is now equal to 25, because that's a squared. So
Yeah.
what I did is now I moved on to the second equation. And since this is 25, I know x plus y is equal to 25. So x must be equal to 25 minus y.
Then we also have x minus y equals 9.
Yeah. But so I just used 25 minus y minus y plus 3 equals 12, or 25 minus 2y equals 9. So then
You can also add these.
Okay.
Yeah, just add them.
That shows that 2x is equal to 34, or x is equal to 17. And then 25 minus 17 gets us to 8.
Yeah, exactly. So in this question, trying to solve for this, trying to solve for like the equation itself using system of equations, you guys can tell it is going to be a headache. It's going to take you all day long. Well, not all day, but it's going to take you a while. So that's why we set some variables to represent expressions, and then we solve for the variables, which made solving for the expressions easier. Does everybody understand how we approach that question?
Yeah. So what really matters when you're doing like these AMC problems, like the more practice you do with linear equations and math calculations, like the faster you'll become at it. Like you'll become really fast when you're doing these kinds of things. But what really matters is you understand the way or like the method that you use to solve the problem, because these kinds of problems, like these kinds of methods, they'll show up like repeatedly and repeatedly on many of the year's exams. Like if you're going to
They only
do
have a
practice
limited
exams, like
number of questions they can ask, like a limited number of methods. So if you just solve more questions, you'll be able to know all of them.
right, like being able to understand what clever manipulation you have to do and how like the method in which you solve the problem, the procedure you use, that's the important part, not knowing that 5 plus 5 is equal to 10.
Okay,
Rashab is gone.
so
Okay.
let's go back here. So we did have some more simple application problems, but you guys can like look at that on your own time, and they're more simple. So it's just like a Jamboard with 5 questions. So you can look at that on your own time since you all have.
I'll send the link in the chat right now, but right now we're going to be moving on to arithmetic sequences. So there's the Jamboard for anyone who wants to look at it, but right now we're going to be doing arithmetic sequences.
Yeah, so right now you should probably pay attention to like our presentation first.
So what is an arithmetic sequence? So in an arithmetic sequence, each new term increases or decreases by the same value for each time. The same value each time. So for example, like 1, 2, 3, 4, or 5. 1, 2, 3, 4, 5, like that's a sequence. and it's increasing by 1 every single time. That's how the new term in the sequence is being determined, by adding 1 to the previous term. Another example would be like the even numbers, 2, 4, 6, 8, 10, 12. 2 is being added every time. And the same thing with the odd numbers, so 1, 3, 5, 7, 9, 11. 2 is being added every time. So in an arithmetic sequence, the number being added to the last term every time is known as the common difference. So in the chat, can somebody type what the common difference or the common differences are going to be for each of those 3 sequences, example sequences that we gave? Yeah, so it's going to be 1 and 2. So to get from 1 to 2, you're going to add 1, right? And then to get from 2 to 4, you're going to add 2. And then to get from 1 to 3, you're going to add 2. So that's the common difference for each of those 3. Okay. And then next slide is just some general rules to keep in mind when you're looking at arithmetic sequences so you guys just don't get confused.
So about the numbers themselves, they can just be anything. So all those numbers we just looked at first were integers. They can be negative, fractional, basically whatever, so as long as they're like numbers, it can just be anything. So those are just like simpler examples. And so about the distance, so like the distance between the numbers, it can also be negative, fractional, whatever. And this difference is called the common difference. So the difference between like 2 consecutive numbers in a sequence is called the common difference. And lastly, some sequences are not arithmetic. So all arithmetic sequences have a rule that repeats. So like the common difference can't alternate. So if you look at this one, 1, 3, 4, 6, 7, 9, 10, 12, 13, you first add 2, then add 1, then add 2, then add 1. So here we're still adding, we're not like multiplying or something. But since the difference, there is a pattern, but since it's not the same each time, this means that this is not an arithmetic sequence. So yeah, if it multiplies, that's also a different type of sequence. So arithmetic sequences, you just add the same number again and again.
So we're going to practice finding the common difference. And so we're going to have the first example, 4, 8, 12, 16, 20, 24, 28, 32. Everyone should type the common difference for this one in chat. Like I'm going to give you guys 10 seconds. Everyone should type it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Well, this is sad, guys. Like we had, okay, so the answer is 4, right? And that's because like you see that you add 4 every time to get to the new term, and like that's how simple common difference is. Like you just add 4 to get to the next term. Like that's all there is to it.
Okay, so our second example is also very simple. So everybody should be able to put the common difference in the chat. So please, like, if you know it, please just type it in the chat so that we know that you're paying attention and stuff. Okay, so I see a lot of -5s, and you guys are correct. So -5 is the number being added to each term to get the next term in the sequence. So that's why it's -5.
Okay. All right. So the next common difference example, yeah. There's not really much to it. Okay, see 4 answers so far. Oh, okay. Okay, yeah, so the answer here is going to be 2/3, and you see that you're adding 2/3 to get to the next term in the arithmetic sequence, right? But there's more to arithmetic sequences than just a common difference in what term you get next. So here we're going to have a little more of an intuitive example or something that you guys can actually solve for. So an arithmetic term has a first term of 3 and a common difference of 5. What is the 9th term? So this one requires a little more IQ. Right, so Shrain says the answer is 43, but Advika says it's 48. Aishwarya says it's 48. Okay. Santoshi says it's 48. Okay. Okay, Tanisha says it's 48. Fishwall, what do you think? What about Sahil? Or actually, Sahil said it was 43. Never mind. So Vishwa says it's 48. Hannah, what do you think? So mostly everyone is saying 48. Hannah says it's 43, and that's all right. That's good. Train says that it's 3 plus 5 times 9 minus 1, and that would be 43. And the answer here is actually going to be 43. And this is because 3 is going to be the first term, and we add the common difference to the next term, right, to get the next term. So we added 8 times to get to the 9th term because, because the first term is already 3. So it's going to be 3 plus 8 times 5, and that's going to be 40 plus 3, and that's 43. All right. So does anyone have any questions? Because I saw a lot of you guys thought it was 48, which is like 9 times 5 plus 3. Have we already had our 5-minute break? No, I don't think so.
We'll have it soon.
Yeah, we have it like almost right after this. We have it right after this.
Okay.
So another example. The first row, oh wait, never mind. This isn't my slide. Oh wait, actually it is.
You can
The first row of this figure has 1 circle. The second row has 2, and the third row has 3. How many circles will be in the 100th row?
So this question kind of is like, it's really simple, but they're adding the figure there just to help you visualize it, I guess.
Shrayan, I think we're not asking how many total circles there will be. We're asking how many circles there are going to be in just the 100th row.
Yeah. So what is the 100th term of this sequence?
No, that's fine. That's a common misunderstanding. Yeah, so it's going to be okay. Yeah, so it's going to be 100, right? As you go to the next row, like the first row has 1 circle in it, the second row has 2 circles in it, the third row has 3 circles in it, the fourth row has 4 circles in it. So what do you think the 100th row is going to have? It's going to have 100 circles because every time you're adding 1 circle to the row. And the sum of those circles, by the way, if you go back to it, that's actually like the triangular numbers. If anyone knows what the triangular numbers are, the sum of those rows, or like what Shrayan was doing, those are the triangular numbers. And basically it's going to be 1 and then 3, then 6 and then 10, because because each time you're like adding a new row, and you're finding the total amount of circles in the entire triangle, and that's known as like the triangular number pattern. It's really cool.
Yeah, if you take like another one of our classes, you'll learn about it. So we'll have our break now. So just please be back here by like 11:08-ish. So, and if you have any questions right now, then you should probably ask right now. Okay, so somebody asked if you memorize triangular numbers or if there is a formula. And basically, I don't want to go back because like our timer will reset, but we saw like the circle. So there's 1 in the first row, 2 in the second, 3 in the third. So you're just adding more circles as you keep going down. And triangular numbers would just be like the sum of the rows as you keep going. So our first term is just this lonely circle, so it'd be 1. And then our second triangular number would be both of these rows added together. So 1 plus 2 is 3.
I see how it makes like a triangle.
Yeah, like a triangle like this. And then our next biggest triangle you can make basically is by adding these 3 circles. So then this triangle, the sum of the circles in this triangle is 6. So as you keep going, you're just gonna add more and more to get like the next biggest triangle basically. So there isn't like, well, I guess it would just be adding 2, then adding 3, then adding 4, adding 5
Yeah.
without your formula.
Basically the pattern is it's just like 1 and then 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4, and then so on. And there is a formula to find the nth triangular number, but like I suggest that you don't look at that formula unless you actually understand the concept behind it. Because like because in math counts you need the triangular numbers, like the formula that's there for triangular numbers, like that's going to be really commonly used, and you really need to understand its applications and why you do what you do with it. There's no point in just mugging up a formula and then like incorrectly using it for everything.
And what Advika is talking about was in the question before. But we were just talking about like the actual triangular numbers. So yeah, we have like a minute left. Yeah, no problem. Okay, our time is.
I'm so scared.
I know, right? It's so scary when you're like not paying attention. Okay, so our break is over and we are going to move on to, oh, first we're gonna do this. So, okay, think about what similarities you see between an arithmetic sequence and a linear equation in slope-intercept form. So a linear equation in slope-intercept form is this: y equals mx plus b. Oh, that looks really bad, but that's y equals mx plus b. So hint, try to connect like this slope and the y-intercept to different parts of an arithmetic sequence. So kind of just like, if you think about it a little bit, you'll get what we're trying to tell you. So they are constant and they can all be represented on a graph as a straight line. So that's like all true, but we want to go a little bit further. Okay, so I see a correct answer in the chat. So if we get one more person, then we will go over it. And guys, so if you want to be able to go to the more fun problems and Kahoots at the end, if you participate a lot, then we'll be able to move on quicker instead of having to wait for you. So if you know something or have a guess, then please just like take a stab at it. It's okay if you're wrong. So I'm guessing all of you guys saw the answer in the chat that said the y-intercept is the start number and the slope is our common difference. So yeah, basically like this slope is our common difference, the number you add each time. I'm just gonna say that's this C. Then this y-intercept is our starting, like the first term in our sequence. So that's like a sub 1. So that means that's our first term. And then y would be like our nth term. So like a random term in our sequence. And then this x would be like n. So like which term it is. Like it's like the 5th term, the 9th term, like that. Since basically we're just starting with this number and adding the common difference a certain number of times to get a term in our sequence. So if that makes sense. Okay, so let's go to the next slide. So to calculate the sum of all terms in a sequence, we have to use this formula. And we don't want to just blindly memorize this and use it, because this one is pretty easy to understand, and once you understand, it would be much more helpful for you instead of just knowing the formula. So it says that the formula is 1/2 times the sum of the first term and the last term in a sequence times the number of terms. So for example, the sum of the first 8 positive integers would be 1/2 times the first term plus the last term, because we're using the first 8 positive integers, times the number of terms, since it tells us there's 8 terms. And that we know when we solve this, we get 36. So it's a pretty simple formula and it works like that. So, but like, why does this work? We know that's right, but why does it work? So now we're gonna look at an interesting diagram. Oh, oops. Okay,
So,
yeah.
you can do it.
Oh, okay. So we're first gonna draw these block images to represent this sequence. So 3, 5, 7, 9, 11, 13, 15. So like the odd numbers starting at 3. So our first term would be these 3 blocks. Then the second term, these 5 blocks, all the way to our last term of 15 with 15 blocks in a row. And then if we look at all of the terms together, so this is 3, this is 5, blah, 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 all the way to our 15, we kind of see that it resembles some sort of shape that kind of has this jagged edge. So if we just kind of cut off these little pieces that are going over this line, and it's kind of like a puzzle. So if we use these pieces to fill some of these gaps that we see here, then we can see, yeah, so like that, those little pieces, if we put them into the gaps, we can see that it is just, that is just a trapezoid. So, and if you know how to find the area of a trapezoid, if you learned this at school or something, so it's just 1/2 times the sum of the bases. So the bases are just the top and the bottom. So that means we would just do 1/2 times the sum of the first and last term multiplied by the height. That's the formula for the trapezoid. And the height here would be the number of terms. So that's why we can get this equation that we saw in the beginning, 1/2 times the sum of the first and last term multiplied by the number of terms. So if we represent it as a trapezoid, we can see that it, like why it makes sense. And this would work for any arithmetic sequence, since the trapezoid would just get like more, like either like wider, longer, shorter, more slanted, but it would still be a trapezoid and it would still work. So yeah, so that would just be the equation you get. Sorry guys, I'm trying to move around a ton of tabs. And okay, there we go.
So the sum of an arithmetic sequence. So let's use a sequence with the first term of a common difference of b, n numbers, and the last term of a plus b times n minus 1.
Wait,
Okay.
sorry, can we go back to this other one? Because somebody is saying that in the end of 15, it isn't a full square. So sorry, but are you talking about like, okay, so we're just gonna go back to this image. So basically, we're not like putting this part into here. We're putting this small part into this small empty space. Then this one is a little bit bigger, so we're putting it here. This one is bigger as well, so we put this here. Now this bigger.
No, I was saying that like if you look at the very bottom at the 15 row, there's like these triangles and uneven squares. So
Yeah.
how count that as the base of 15?
So this is just a trapezoid. So a trapezoid is like, it can look like this, or like what we see right now. And the formula for a trapezoid is 1/2 times the sum of the bases. So the bases are just the length of the top and bottom side, the ones that are parallel, times the height. So it doesn't matter if this like is incomplete, like this little triangle and this incomplete square, that doesn't matter, because for a trapezoid, you just find the length of this bottom line, like the bottom side. Does that make sense?
Kind of, but I'm just saying like there's like this triangle at the end, at the very end, and all that. So how would that fully become into the whole 15 without it being a decimal or fraction?
Because this part, this piece that's missing, it went over here. So we're just moving these pieces around. So before it looked like a blocks like this. So it's just the same thing, but we're just rearranging, like cutting off some of these ones that are coming off the side of this line and then putting them back into some of our missing pieces so that we can form a trapezoid. So nothing is missing. We're just like cutting some parts of this shape and putting it into our empty spots.
Okay.
Okay, hopefully that makes sense. Okay, now let's go back to our order. Okay.
So, all right, again, so the sum of an arithmetic sequence. So let's use a sequence with the first term of A and a common difference of B. So, and then this sequence isn't going to be infinite. It's going to have it's going to have a set amount of numbers, and there are n numbers in this sequence. The last term is going to be A plus B times n minus 1. So we're going to try finding the sum of this arithmetic sequence. Does anyone have any ideas on how to do this?
First of all, does everybody understand why the terms are written like this? If you do, can you like say yes in the chat? Okay, I see one yes. So once we see that like a lot of you guys are saying yes, we'll move on. Because if you don't understand this, then you can't understand the next one. So far I only see 3 people that are saying they understand. So it's okay if you don't understand. You just have to say that you don't understand and we can explain it more.
Yeah, just if you don't understand, like just let us know. Like the point of this class is to help you guys. Like if
Yeah.
you're not gaining anything from this class, then somewhere something is wrong. Like you guys also need to communicate with us as well.
So does everybody understand why the terms are written this way?
Okay. All right, then I'm just going to go over finding. Okay. I can actually use a different example other than this because this one's kind of weird. Like I don't like looking at variables. I like looking at actual numbers, like what you're supposed to do in math. So let's like practice and let's try finding the sum of the first 100 terms. Like the first 100 like numbers, like 1 through 100. So does anyone have any ideas on how we would do that? What is the sum of 1 plus 2 plus 3 plus 4 all the way until what is it? 98. I'm typing it in chat. Okay, so let's practice, or let's try finding. Okay, actually, apparently some people have some questions going over, or questions understanding the variables, and this right here, the sequence here is just an arithmetic sequence, and the way that it works is we have our first term, which is A, and then we add our common difference of B, and then to get our second term, and then we add it again for our third term and for our fourth term, and so on. And basically, since this sequence can be any length of numbers, we're going to have to specify the length of numbers with the variable n, right? And n represents the number of terms in the sequence. So and remember how we did the example where we found what the ninth term of an arithmetic sequence would be if it had a first term of 3 and a common difference of 9. That's where that n comes in, because it's like, remember, n minus 1 times the common difference plus a, and n represents what term that number is. And so here we have the ellipses in the middle, and we get closer and closer to the end of the sequence, at the end of the arithmetic sequence. So that's what n represents. And basically, this is just going to be your typical arithmetic sequence. And the way that I like doing the sum of the first 100 numbers is by the sum of like the first 100 numbers. The way I do it is I look at the sum of the pairs of the numbers times the number of pairs. And what I mean by when I say pairs of numbers, I mean like the sum of the first and last number. So for example, like I'll wait for Kayang to finish drawing the thing.
Yeah. Almost there.
It's actually 96, I think. It starts with 96, not 95.
What do you mean?
It's fine. But basically, what I mean by pairs of numbers, it's the numbers correspond, like the 100 and then the 1 correspond with each other, right? So that makes one numbers, and that sum is going to be 121. And you can keep making these pairs with like 2 and 99, 3, 98, 5, 96, and like so on. And we find that that common sum is going to be 101, right? And then 101 times the amount of pairs that we have, because we're just repeating that addition of those common pairs, right? And it's 101 times, and how many pairs would there be, right? How many, can somebody type in chat how many pairs there would be? Right, there would be 50 because there's 100 numbers, right? And so then each pair would consist of 2 numbers, so there would be 50 pairs of numbers. So our answer would be 101 times 50. All right, and that's the way that I learned it.
Yeah.
And whenever I do like questions, I always look at it that way, and I'm able to find it. Are there any questions about that method? Because it may seem a little confusing, but if you like understand it, it would be really good. Are there any questions about that?
So using the variables, there's some like less messy, I guess. It's like the same thing, but this time instead of using actual numbers, we're using variables to represent just like arithmetic sequences in general. So we just do the same thing, add the first and last number, and the sum stays constant as we add, like, get rid of the first and last numbers and add the second and the second to last numbers. It's still gonna be 2a plus b times the quantity of n minus 1. So we just multiplied that by the number of pairs, like we did for the sum of the first 100, and that gets us the equation that we had. Yeah, so this is the explanation we just showed you guys in words. Oh, and a common question that would come up is, what do we do if there's a number in the middle? So what this means is, like, if I have 1, 2, 3, 4, 5, I have this pair, right? So this 1 plus 5 is 6. And then 2 plus 4 is also 6. But what about this 3 in the middle? What do we do about this? You could ask. And first, it might not seem too obvious, but if you realize that 3 times 2 is actually 6. So since we're dividing the number of terms by 2, so right now we have 5 terms, right? So 5 over 2 is 2.5. If we do this, the 2 accounts for the 2 pairs of 6 we have. So this one and this one. And then this 0.5 accounts for our lonely 3 in the middle. So everything would still be accounted for, even if there's an odd number of terms, or if there's an even number of terms, it obviously works. So you just have to use the same equation, and it would work every time. Yeah.
So now I think we have to like immediately skip to just what the homework for this week, so that I can post the link and stuff in chat. But if anyone has any questions and wants to like stay a little bit and ask them, because today's class I think was a little confusing for a lot of people, you guys can go through that, or you guys can stay and ask some questions. But for now, you guys have, since we will do the Kahoot.
Will we do the Kahoot?
Will we do the Kahoot? No, we don't have time. Class is supposed to be ending at 11:30, right? So I'm just gonna post a link in chat for homework, and just remember, finish this by tomorrow. And if you have any questions regarding it, you can like stay and maybe ask.
Yeah, thank you guys for coming. And we did go over like everything we were supposed to learn, and we did use an example just without going to the actual example slide. So you should have learned all the content, but if you need some extra help, we can obviously help.
It was just a little rushed, that's all.
Yeah.
Bye.
Bye. Have a good day.
Let's see, like, how are